Hello everyone. We would like to present microservices and Kubernetes benefit in today's world. So let's understand it with a persona. He's Paul, a solution architect. He met with a client who honored him with a new project and wanted to propose architecture. Paul discussed the key requirement of the project, and those were: it will be a big and a complex level enterprise application. Many technologies and multiple platform support will require. Frequent development, testing, build, and development cycle will require. High performance and zero downtime is the key requirement. The solution should be scalable and secure. Then he thought, should he go with the monolithic architecture or microservices architecture? So, monolithic architecture is like a big box and microservices are like the small boxes. At present, most of the applications follow the monolithic architecture, which is based on the technology stack and deploy as a single package. If this monolithic application is down, then whole system will get down. Paul had worked on the monolithic application in the past, so he was aware of the monolithic architecture challenges. Those are block CICD. As everyone is independent on each other, it is difficult to implement CI/CD with monolithic applications. Unscalable. Monolithic applications are not scalable in terms of handling large user base. Inflexible. That means monolithic applications are developed using one technology stack. We cannot create individual modules in different technologies. Unreliable. Monolithic applications are unreliable. If something fails, then whole application will go down. There is no fault tolerance in such application. Slow development. Due to technologies on modules, wait time is more in the monolithic application, so development activities get slower here. Large and complex application. In long run, monolithic application complexity increases and it gets difficult to manage. Then he explored microservices and Kubernetes. And he created a plug-and-play framework. In this framework, he has used microservices architecture and Kubernetes to manage microservices. In this framework, he has created 4 microservices, which are built using 4 different technologies, that is PHP, Python, Java, and .NET. There is a service discovery module, which helps in discovering active and available services. If there is one more module, that is API gateway, which work as a firewall to filter the request and make the application more secure. Using Kubernetes, he also got monitoring dashboard to monitor the microservices, log analysis for centralized troubleshooting, and config manager to manage all the services config from one place. With this architecture, Paul has achieved. He has achieved the features like zero downtime deployment. With microservices architecture, we can have zero downtime deployments, auto-scaling. Kubernetes provides auto-scaling features. It means if there is load on the application, it auto-scale as per the configuration we have set. Support many technologies or languages. Microservices can be developed using any technology, which communicate with each other using APIs. Load balancing. Load balancing is a well-known feature. It is very easy to implement using microservices and Kubernetes. It provides good interface and monitoring for it. High availability. Microservices and Kubernetes provide high availability of system. Container orchestration. Microservices fully support container orchestration and Kubernetes provide a good interface to manage it. Automated scheduling. We can schedule automated deployments for frequent builds. Secured environment. Fault tolerance. This feature of Kubernetes helps in any disaster happen with the container. If one container goes down, it will automatically create a new pod and make it available for the users. Centralized logging and monitoring. Kubernetes provides centralized logging and monitoring system which help us to debug and monitor the issues and warnings. Config management. Centralized config management helps in managing microservices at one place. automated rollouts and rollback. It helps in deployments and rolling back the deployments if any issue occurs. And with all these features, Paul has created a wow for the client and team. So, Persona ends here. Now, let's see the proof of concept created based on this framework. We have created Guess Who application and a mobile app which works on Microservices plug and play framework. You can see here that there are 4 different technologies has been used to create the microservices, and each microservices has its own database which makes the application independent. Microservices can talk to each other through APIs. Now, we would like to give you a demo of Kubernetes and would like to share the benefits of microservices using Kubernetes.
With the demo session now. Here we can see the Kubernetes dashboard. First, let me introduce you to the Kubernetes. Kubernetes is nothing but open source container orchestration tool, which is used for managing one or more containers. Here in our application, we have several microservices, which is built on top of several containers. And all of these microservices are managed by Kubernetes. So here we have 4 microservices for 4 different platforms: PHP, Java, Python, and .NET. And for these 4 microservices, we have 4 pods. Pod is nothing but collection of one or more containers. So now let's start with the features demonstration now. So first, let's start with a zero downtime feature. Zero downtime feature, we are able to deploy new release with a zero downtime. So now let's connect to the Kubernetes server through the PuTTY session. Here I will be executing the command for the new release. So here, it is our Gateway application, the original application before the new release. So now new application is being deployed. After the refresh, we are able to see our new application is deployed successfully. Here the text play is been appended on the UI. So this release is being done with a fraction of a second with the help of Kubernetes. Yeah. So the next, let's see the next feature, that is rollback feature. If now the situation comes that our release contains bugs and many much errors, so it is mandatory for us to roll back our release. So now Kubernetes also provide feature for this, that is rollback, using which we can easily roll back to our previous deployment. Just execute command for the rollback and we will be able to see the previous deployment on the UI. Yeah, yes, on the UI we can see the Gateway application is being deployed with the previous release now. So now let's move to the next feature, that is load balancing feature. So on the Kubernetes dashboard, there are services. Go to the services and here we have 4 different services for our 4 different microservices. Services are nothing but means using services we are able to expose our microservices to the environment internally in order to connect them each other with the help of APIs. So for the PHP microservice, we do have 2 endpoints here. So whenever the user request comes, that will be served by one of this instance. These 2 endpoints are nothing but these are 2 containers, that is 2 pods. So here I can also tell the next feature, that is fault tolerance. If we have given in the deployment definition that we are deploying 2 pods, means 2 containers for the same microservice, and if for any reason one of the instance goes down, it will be resume or instantiate a new instance automatically for us. Means all of the maintenance and managing the containers is being all over handled by the Kubernetes itself. So now let's move to our next feature, that is monitor dashboard. So in Kubernetes, it is using Grafana for the monitor dashboard purpose. Here we are able to see the CPU and memory usage for the specific pods, or in our case we can see different microservices, PHP, Java, we can list those and see the CPU and memory usage for our microservice. And we can have idea about how much CPU and memory utilization is done by our particular microservice. And this Grafana dashboard is also customizable dashboard where we can add more graphs here. So now let's move to our next feature, that is ingress, which is nothing but API gateway. API gateway is mainly used for filtering and traffic routing to the app server. Means traffic routing is mainly controlled by rules defined on ingress resource. The most important role the API gateway plays is ensuring reliable processing of every API call. Let me show you the ingresses that we have defined here for our microservice. So currently for the PHP microservice, we have defined API gateway. And here in the rules, we have written a rule for the PHP microservice that whenever the request will come from this DNS, that is guesswho.com, it will be internally redirected, filtered, and request will go to the service named as guesswho.php. Means here we can write many of the rules for filtering our user request, and this ingress will act as a single entry point to our server. So I'm now done with the demo. We have other features also for the Kubernetes. Those are auto scaling. The second one is config service. So freely come to the microservices team if you want to see all of these demos here. Thank you so much.
Thank you everyone. Microservices सही है.